Hi guys, this is Dakshat. So today's topic is gonna be arrays. So we'll be seeing what is an array and what will be the type of complexity when we are doing the insertion, deletion, and then when we are retrieving the information from the array, and then when we are modifying the stored data in the array. So what is an array? Array is array is a collection of same data type which is stored in a continuous memory. Suppose this is an array. Here we are given that 2, 4, 10, 5, 15, 3 are stored in an array. So suppose if the data is stored somewhere, let's say it is an array, and then we need to retrieve that data. So that will happen when we have some certain conditions on particular data type. Like if we have array, then we can retrieve that data using index. So the array initialization will always start from 0. So if you want the first element, then we are going to call array of 0. And then when you want to retrieve the second element, it's going to be array of 1. So whenever we want the first element or nth element, then we are going to call array of n minus 1 index element so that we'll get the nth number. So that is the uh, topic behind this array. So if we can see this, it is pretty much the same. Like we can store the data in continuous memory location. Like the data will be stored in continuous memory location. There can be different arrays. It can be 2D array, 3D array. So it can be 2D array and then 3D array. If you come to 2D array, then these are going to be columns and these are going to be rows. So it will start from array of 0, 0, and then this will be the zeroth row, and then this will be the first row, and then this will be the second row, and then this will be the third row. As we are given, like it is a row number 1, but the array initialization starts from 0. So this is going to be, if we take 0th index, then this is going to be the first row, but with 0th index. This is the second row, but with 1th index. This is the third row, but with second index. So it is going to be like this. And then there will be different implementations based upon different languages. Suppose, let's say, if you want to initialize the array in C++, we are going to do with using the data type. This is going to be the data type, and then this is going to be the name, and this is going to be the size, and then we can give the elements like this. So, and whenever we want to modify the particular element in an array, we are going to assign array of 3 equal to 15. So for C, it is going to be like pretty much same, but uh, some of the things might change. So in Java, here we are going to give like integer brackets and then array and then 1, 2, 3, 4, 5. So for in Python, you don't need to mention which type you need. Like it can be int or you can give directly declare the numbers itself, and when you want to modify, you can modify. And then when you want some specific syntax for array or any particular type in any particular language, you can use the Google search. You can just Google search it, and then you can get the syntax, and then use all the all the scenarios and then all the functions which are present there. So you can use the chat GPT as well. Suppose if I want the syntax of arrays in different languages, you can just type the prompt and it will try to give all specific details. But we need to play in such a way that we will give the correct prompt. So it will give the almost correct answer for all the syntaxes. So you can use this. So suppose if you want 2D array, so how can we declare with C and C++? It is going to be like two square brackets, and then we are going to mention the size 3 and 4. And what about Java? It is going to be two brackets, and then we are going to assign the elements like this. So we can use the technology we have. You don't need to mug up the things, but when you want to code really fast, you can get the syntax by solving more number of questions and then by understanding the syntax. Syntax is just kind of a language. The logic doesn't change, the pseudocode doesn't change, the way of thinking doesn't change. So syntax, suppose let's say you are writing the program in C++ plus plus, and then you want to get the particular code in Python. You can just copy paste the code, and then there will be some of the websites, and then there will be like you can use ChatGPT as well. Suppose if you want to convert C++ code into JavaScript, you can just give the prompt, and then you can copy paste the code, and you will get the result. And you can use that code to get in Python or JavaScript. So you don't need to worry about the language. You can just pick one language which you are familiar with, or you can take any C++ or Python. It can be your choice. And then when we have any data structure, we need to know the in and out of the data structure. Why we are going to use it? Why? What is the time complexity it is going to be? Suppose let's take an array. Suppose this is an array, and we are given 1, 2, 3, 4, 5. So here, there are going to be different operations which we'll be doing on this particular array. So you want to access the element by an index. Suppose this is one-dimensional array. You want to access the element. Suppose let's say I want to access 1. Then you can access ARR of 0. It will be, you know the index, you know the memory address. So you will get very easily. Then because of that, the time complexity is going to be big of 1, because it doesn't take time if you know the index. And it is going to be same for 2D array as well. Suppose I want this particular element which is present at these indexes. Then it is row 2 and then column 2. Then array of row minus 1 and then column minus 1. So accessing of element by knowing the index is time complexity will be big of 1. And what will be the space? We are not using any extra space to get the access of the element by using the index, right? So it is going to be big of 1. Suppose let's say you want to add an element at the end in an array or in any two-dimensional array. Suppose let's say you have 1, 2, 3, 4, 5. You want to add 6. What you will do? You will just increase. Suppose let's say you have 6 elements. Now you can push back new element which is 6 at the last. So the time complexity will be only one operation we'll be doing at the end. We are not changing we are not changing all these elements which are present previously. So we are not going to do anything to this. We are just pushing the last element which we need to push to the particular array. So it will be same for a two-dimensional array as well. So suppose let's say we have two-dimensional array and we want to give one more element. So we are going to push back into that element. And then let's say you are inserting an element at the end, at the beginning. Suppose let's say you have 1, 2, 3, 4, 5. And now I want to insert 0 here at the beginning. So what are we going to do? So there can be, here it is given that it will be big of n time complexity to insert at the starting. So if you see, accessing the elements, inserting and then inserting at the end, inserting at the beginning. Inserting an element at the beginning of one requires a shifting of all the to make a room and linear time complexity. And then For I'm showing this because there can be different scenarios. Inserting element at a specific position. Yeah, let's see what I want to see. Say let's say suppose this is particular array and I want to insert 0 at the starting. 0 at the starting. So when you want to insert 0 at the starting, there can be let's say you do not want to know order can be anything. You just want to insert 0 at the first index. So if you do not want the order which is present previously, then I can say, let's say I store temp variable somewhere 1, which is present at the starting, and then I'm going to insert 0, and then there will be 2, 3, 4, 5. So this is going to be, I inserted 0, but one more element is present, which is not, which we had removed. So as I mentioned, the order is not important. I can insert at the starting. So the time complexity will be big of 1 when order is not important. When order is not important. But when you want the same order, then you are going to say here it will be 0, and then you are going to shift every element which is present in the array to the right. So you are going to shift for all the elements, which is going to be big of n time complexity, right? When the order is not important, it is going to be big of 1, and it is going to be big of n when order is important. Yeah, that is one thing which I want to mention. So this depends upon the specific condition which it is given in the question or the interviewer asks. So it is going to be like that. And then when you want to search an element in particular array, so it is going to be big of n. Suppose let's say you want to search an element 3 here. So I want to search an element 3 as the string as the array is in sorted order. We can search it via binary search, and then we can say the time complexity is going to be log n. For binary search it is going to be log n, and then for linear search, let's say you are going to visit each element and then find whether 3 element is present or not. So then it is going to be linear search. Linear search when we don't have any order in an array. Log n when we have order in an array, right? So when we have an order, we can do the binary search. When the order is not present, then we need to visit each and every element and then see whether the element is existed or not. That time complexity is going to be big O of n. And then when you want to transpose a matrix, suppose let's say transpose a matrix, it will not be present in an array. Suppose let's say you want to reverse the array, then what is going to be the time complexity? You are going to swap the first element and then last element. So it will be big of n time complexity. It is kind of transpose. You can say transpose of an array. So it is going to be big of n time complexity because you are going half of the size of the array and you are going to swap with right side. And what will be the time complexity for this one? We are going to transfer rows to columns and then columns to rows. If we are going to use more space, then we are going to take more space. I think transpose of matrix you can do without using more space. That will be optimizing based on that. Suppose let's say you want to delete an element. See, whenever I mention the time complexity, it is going to be the worst time complexity. Suppose let's say I'm saying deletion of an element. Let's say we have 1, 2, 3, 4, 5. So when you want to remove 5, then you don't need to touch all the first four elements. You can just remove the last element. So that the time complexity will be big of like 1. But when I say big of n, then we are going to consider the worst time complexity. What will be the worst time complexity when we are deleting an element present in the array? So for this one, big of 1, big of 2, big of 3, big of 4, big of 5. Big O of 5 is big O of n, which is of size, array of size n. So it is going to be big O of n when we want to delete an element present in an array. So that is what they are mentioning. Suppose if it is matrix, it is also same. Suppose if I want to delete this particular element, so if you want to get this all elements like here, then it is going to be, suppose let's say this is m rows and then this is n columns. Now I want to remove this particular element. So we can we can say we'll transfer all these arrays like this. So it is going to be big of n, which is number of columns present in the matrix. Suppose if you want to bring all these rows to here, then it is going to be big of m. Why? Because you are changing only these elements which are present here. Suppose, let's say, I want to bring all these elements like this in particular order. Suppose, let's say, I remove this. So this elements gets here, and this elements gets here, and this element gets here. This element will get here. This element will get here. This element will get here. So if we want the same order, then it is going to be big of all the elements. All the elements will be m and n. So that will be the time complexity when we are dealing with different operations on particular array, whether it is 1D array, 2D array. So that is the topic for this particular array. Yeah, thanks for watching. Do subscribe to the channel if you like. If you like the video, just like it. If you don't like the video, dislike it. Thanks.